Hello friends and welcome to Physics Lover. I have changed my channel name from The Laughing Monkey Official HD to Physics Lover as I am in love with physics and in love with this book especially. So today let's focus on question number 7th of this book of the first chapter Mechanics. Let's read out the question. The question says that two swimmers leave point A on one bank. One of them crosses along the straight line AB while the other swims at right angles to the stream and then walks the distance that he has been carried away by the stream to get to the point B. What was the velocity u of his walking if both the swimmers reached their destination simultaneously? The stream velocity v naught is equal to 2 km per hour and the velocity v dash of each swimmer with respect to water equals 2.5 km per hour. It in turns you like that it is a very lengthy sort of question, but actually it's very easy. If once we grasp the concept, the question becomes a child's play. So let's draw the picture of what question says, and picture will say solution of this lovely question. So let's draw the lovely drawing of this question. Say this is a river, and the river is not flooded actually, it's just a river. And this is flowing like this. As you see while you're rafting, there are a lot of currents in the water, but it's going with the uniform velocity v naught over here. So from here we can see that if the swimmer A was up till point here and the B point is over here, and both the swimmers at time t is equal to 0 were present here, and for the first swimmer, let me write here velocity of swimmer equals v dash velocity of stream equals v naught. So for swimmer 1, let me turn over the page. Let me focus it over here. Right. For swimmer 1, let's think about the situation for swimmer 1. If the stream is flowing in this direction like this, and for swimmer 1 he has to reach from point A directly to point B, then it means it somehow moved at this some sort of angle with the stream, or say the vertical, to reach this point B. This velocity was equal to v dash and this was equal to v naught. So what about this velocity over here, AC? This would be simply equal to v dash square minus v naught square. So if we have to consider situation in AB, then we have to divide it by v2 minus v naught square so that we can get the time for swimmer 1 to travel from A to B. So the time, let me write the velocity of swimmer 1 along AB, as I have shown you in the diagram, it's equal to v dash square actually, v dash square minus v naught square whole root. Kilometer per hour as it's in the question. So this is the velocity of swimmer 1 along AB. So that let swimmer 1 take time t1 to reach B. So this time t1 will be equal to AB upon whole root v dash square minus v naught square. Right? This becomes our first equation over here. Now let's think about the swimmer 2. Swimmer 2 condition. So for swimmer 2, let's think about the situation in diagram. Swimmer 2 at its initial position travels 90 degree over here, 90 degree with the stream like this. And so if there is a velocity v naught over here, then he must have been displaced by some of the distance over here. that it really reach the point D. So over here was V naught, and this velocity over here will be equal to the stream velocity, that's all V naught, and over here it would be V dash, as this is the initial velocity of the swimmer, that was equal to V dash, and this was V naught. So over here, what will the velocity? Actually, we don't need in the question, so we will actually take the regards what V dash and V naught are. So let's think about the situation when this swimmer 2 reaches point D. What time it would take? The time taken by the swimmer 2 to reach the point D would be, what was his vertical velocity? Let 2 takes T2 time to reach D actually. So over here, if it has to travel this distance, this would be actually equal to AB, and this, we are not taking about the horizontal component in this regards, and this velocity over was V dash. So what would be T2? T2 would be simply AB upon V dash. So this gives a third equation. Now as we take here, there was a drift over here. The swimmer 2 was drifted in this distance that we name B is equal to x. So what was the time from going from D to B? It was his velocity u for going from D to B, and this u will give us time t3, that would be equal to x upon u. So I can write it as let BD is equal to x, right? So what was the time taken by the swimmer 2 from reaching from D to B? It would be simply let 2 takes time T3 from going D to B. Exactly what I'm saying. So what would be T3 equal to? T3 would be simply equal to x upon u. So here we have another variable x over here, and we don't know what x is, so we have to find what x really is. So from here we can see that swimmer 2 takes time t2 from reaching A to D. So what would the drift over here? It's horizontal velocity of v naught, and it traveled distance x. So what was x equal to? X was equal to simply v naught into the time taken from A to D. So we can write it over here. X is equal to horizontal velocity would be simply of that of v naught, that of stream. So this would be equal to x is equal to v naught into the time taken reach from A to D, and that time was equal to this AB upon V dash. So this over here is equal to x. If we put it over here, what we'll get? We'll get T3 is equal to V naught AB V dash U. This gives our third equation. Actually third question over here. So what the question is saying next, we have to find the velocity u. So for finding the velocity u, it has seen that both the swimmer reached that point B over here at same time. This means that T1 is equal to T2 plus T3, as T1 is the time simply of swimmer 1 from reaching from A to B, T2 was from A to D, and T3 was from D to B simply. So this was the time for swimmer 2, this was the time for 2, and this was the time for swimmer 1. So both of the swimmer reached that point at simultaneous time. So let me put the equation that we have created over here, and we will get AB upon whole root V dash square minus V naught square is equal to AB upon, what was the second equation? V dash, plus what was the third equation? That's equal to V naught upon V dash, V dash U into AB. So AB are cancelled out. What we will get is this equation over here, and if we put the values that have been given in question, that V dash was equal to 2.5 km per hour and V naught was equal to 2 km per hour, we can simply write it as 1 upon whole root 2.5 square. Now this is basically our numerical part left of the question. The question is almost finished. 2.5 plus 2 upon 2.5 u. So let's find out this u over here. And the u would be equal to whole root, this would be 6.25 into 4, 2.25, which is equal to, in turn, this will take an LCM u over here plus 2 upon 2.5 u, and this 2.25 would be simply equal to 1 upon, let me read out, 1.5. 225 whole root is 115, so there will be a point over here is equal to u plus 2 upon 2.5 u. So 2.5 u, let me make the point more clearly, 1.5 u plus 3. Let me take it over here and I will get u is equal to 3 km per hour. And that's our answer of this lovely problem. Actually, the question is also lengthy, image is not lengthy actually, and the answer is a bit lengthy, but it's very interesting to note that such a great question has a simple value of 3 km per hour over here, and this whole thing solve our question. A picture says 1,000 words, I've said earlier also. So this picture gives a glimpse of the question, and by seeing this picture we can easily find out what our answer could be. I don't have to do this all sort of questions if you will solve all this book right in your next 2 years. So thank you for watching this video, and I hope you would like my name of the channel, that's Physics Lover. I'm really in love with physics and in love with problems in general physics by Irodov. Thank you once again friends, and please subscribe to my channel and put on the like button. Thank you.